Hello guys, welcome back to the quantity surveying workshop and to another video. In today's video, we are going to be treating how to measure the reinforcements inside the chained lintel. Now remember, in our previous video we calculated for the concrete work and the form work for our lintels, and we assumed that the lintels in this drawing were chained. So in this video we are going to be learning how to go about measuring the reinforcements inside the lintels, because you know that the lintel concrete is what reinforced in situ concrete, so we have to also measure for the reinforcements inside the what concrete work for the lintels. So we've done multiple videos where we treated how to measure reinforcements, so whatever I do here shouldn't be anything strange to you if you've been following the videos we drop consistently. Calculating for the reinforcement is not difficult. Reinforcement is measured in tons. So now, how do we calculate the length of our reinforcement? So to calculate the length of our reinforcement, we're going to be starting with the vertical side. So now if you look at this area here, right, the reinforcement for the lintel would pass from here down to this edge. I don't know if that makes sense. We're told that there will be a lintel around here, right? Good. So now it means that the reinforcement is going to pass from here down towards this edge. Now remember, when you are measuring for reinforcement, you have to minus what? Concrete cover, because reinforcement is supposed to be some certain distance inside of the concrete. So if we can determine the length from here to here externally, we can then minus concrete cover from both sides. That will give us the length of the what? Straight bar. Now remember that at each end we have to cater for what? A bend. So there's going to be a bend here, and there's also going to be a bend here. So from what I've stated here, we can now see that the length from here to this edge is given in the dimension here as what? 13,315 millimeters, which is 13.315 meters. And remember, the standard length of a reinforcement is what? 12 meters, or let's just say 11.5 meters. So it means that to get the total length of the reinforcement for this lintel, we have to what? Join two reinforcements together to give us this 13.315 meters, since the standard length of our reinforcement is 11.5 meters. And you know that it is standard practice that when you are joining two reinforcements together, you will add what? You cater for what? Lapping. So we're going to assume that our lapping is what? 600 millimeters. So it means that the 600 millimeters will be multiplying it by 2. Why are we multiplying it by 2? We're multiplying it by 2 because we need to join two reinforcements together to attain this length of 13.315 meters. I don't know if that makes sense. So it means that one reinforcement coming like this would have one lapping, and the other reinforcement coming like this will have the second lapping, to ensure that the two reinforcements are what? Binded together. I hope that makes sense. So now with this, we can now what? Begin our what? Calculation for this straight bar here. Okay, so we are going to be assuming that the thickness of the reinforcement is Y10. That's the reinforcement used in the lintel is Y10. So now we are going to be starting with what? Measuring for the straight bars, the vertical ones. So we're starting with what? The reinforcements that will be inside here. So you know that normally inside of the lintel concrete there will be 4 reinforcements inside, right? But all we need to do now is to determine the length of one. So we're going to be determining the length of one till we finish the entire reinforcement inside of this lintel. Then when we're now booking in our dimension column, we'll multiply it by 4, because all the reinforcements inside of the lintel will be 4 in number each. So we just need to determine the length of what 1. So we're going to be starting with the reinforcement inside here, which I've already explained. So the length is what 13,315, which is this one. So we're going to call this side C1. And we know that the length is what 13,315. So since we know that the length is 13,315, which is the out dimension from here down to this edge, remember we have to now minus what concrete cover. So we're assuming that the concrete cover here is what 25 mm. So we'll now less what concrete cover. From both sides, 2 by what 25, and that will give us what 50 mm. So when you do your maths, you're going to be having what 13,265. So I think that 13,265 is the length of the straight bar inside of this what lintel. So now, like I said before, we're going to be adding what lapping, because this value here exceeds the standard length of what a reinforcement, which is 11.5 meters. So it means that we're going to be joining 2 reinforcements together. Therefore, we have to scatter for lapping for the 2 reinforcements. So by assuming that lapping is 600 mm, so lapping is 600 mm, so we have to scatter it for the 2 reinforcements. So it will be what 2 times what 600, and that's what 1,200. So we are also going to be what adding bend. So it means that if you look at this drawing here, you can see that this inside, this is the lintel concrete from above, that is from the plan view. So you can see that inside there's a reinforcement moving like this. You can see there's a bend immediately after you remove your what concrete cover. Let me zoom in so that you can see it properly. So immediately after you remove your concrete cover, you can see there's a bend. So we have to scatter for the what bend. So now, like I said in our previous video, there's a formula for calculating your bend, and that is what 12D, right? So we will now say add bend. So we know that the formula is 12D to determine the length of the bend for one side, and the bend is going to be found on what 2 sides. So it's going to be what 2 by 12D, that's 2 times 12 times D, and the D is the what diameter of the what bar, which is what Y10 in this case. So we're going to be having what 2 by 12 by what 10, and 2 times 12 times 10 is going to give me what 240. So when you do the maths, what are we going to be having? We're going to be having a total of what 14,705. So this would be the total length of the reinforcements that we're going to be having at this side. That's one of the reinforcements here, spanning here, will be what 14,705. So now if you look at this drawing, right, the reinforcements that we have here would also be the reinforcement that we have here. So it means that whatever we've gotten here, we have to multiply it by what 2 to cater for what this side and what this side, because what you can see that they are the same dimension. So we are now going to multiply this by what 2. So multiply by what 2, and we're going to be having what we're going to be having what 29,410. So 29,410 is the total length of one reinforcement inside this lintel and inside this lintel. So now let me just use a green barrel to demarcate it so that you can know that we've done this. So this is the the lintel that we've cut out for here, and here. So the next reinforcement that we have to scatter for would be this reinforcement here. This reinforcement here. And as you can see, the reinforcement we have here would also be the reinforcement we have here. So I have to cut off for these two reinforcements here. Right. So now, how do you go about getting the length of this reinforcement? We're still going to be using the same process. So now we need to determine what is the total length of this lintel from this edge down to this edge, which is the outside dimension. So we can determine that by adding what 230, which is the thickness of this wall here. Then the length of this bedroom from here to here is what 3,561. Then we're also going to be adding 230, which is the thickness of this wall, and then we're going to be adding this dimension 1,246, which is from here to here. So when you add everything together, you're going to be having a total length of what 5,267, meaning that the dimension from here to here is what 5,267. So now we can now do the maths. So we're going to call that T2. So we know that we'll be adding what 230, 3,561, 230, and what 1,246. I've already explained where we got this dimension from. This 230 is for the thickness of this wall here, right? This 3,561 is the dimension from here down to this edge, as you can see, from here to here. This 230 is the thickness of this wall from here to here, and 1,246 is the dimension from this edge down to the external side of the wall. So now we're going to be having a total of what 5,267. So since we've gotten 5,267, we're going to be lessing what concrete cover. So less concrete cover, which is 2 by what 25, and that's going to give me what 50 mm. So when we less 50 mm from 5,267, what are we going to be having? We are going to be having a length of what 5,217. So it means that the length of the straight bar is what? That's for this straight bar here, one of it is 5,217, which is within the what standard length of a reinforcement. So there's no need for lapping. So we're not going to what add bend to the end at both sides. So I'm gonna add bend. So you know the formula, 2 by 12 by what 10, and that's going to give me what 240. So when you do the maths, you're going to be having what 5,457. So this is the length of one reinforcement inside this lintel. So you know that what we have here is the same thing as what we have here. So I'm going to be multiplying it by what 2. So multiplied by what 2, and I'm going to be having what I'm going to be having 10,914 millimeters. So this would be the total length of one reinforcement inside this lintel and inside this what lintel here. I hope that makes sense. So the next reinforcement, we have to determine with the reinforcement for this lintel passing from this edge down towards this edge here, right? So if I use my green marker to show it, this is the lintel we're talking about here, the lintel here. So now how do we determine the length of this lintel from this edge down to this what edge? Now to determine that, if you go to our dimension, you can see that the thickness of this wall is 230. The dimension from here to here into in is what 6,275, which you can see from here to here, and then the thickness of this wall is what 230. So now we're going to be adding everything together to determine the total length of this lintel from here to here. So let's name it T3. I don't know if you can see this, or let me zoom in so that you can easily see what I'm doing here. So we're going to name it T3. So the first parameter is the thickness of the wall, which is what 230. The second one is 6,275. As you can see here, 6,275. So and then 230. I've already explained how we got these parameters, so all we just need to do is to add them together. And after adding them together, we're going to be having a total of 6,735. So it means that the length of this lintel from this edge down to this edge is 6,735. So what do we do next? We'll have to now minus what concrete cover. So we will now less what concrete cover. Which is what 2 by what 25, and that will give us what 50. So when you minus 50 from 6,735, you are going to have 6,685. $6,685. So after that, we will now add bend. I will know the formula. So now we're going to be having a total of what? That's when you add 240 to 6,685. You have a total of 6,925. So we're going to be moving this dimension to the side for easy correlation. 6,925. So now, doing this, we've gotten the total length of our reinforcement that we're going to be placing for this lintel here. So the next reinforcement we're going to be looking for will be the reinforcement inside this lintel from here to here. So first things first, we need to determine the length of this lintel from here to here. And how do we determine the length? So to determine the length, this is what we're going to be doing. So we know that from here to here is the thickness of the wall, which is, you can see in this dimension as well, 230. Then into in from this side to this side, you can see you have to add this dimension 1,765, 230, and what 1,845. And then we have to also add the thickness of this wall, which is what 230. So basically all the dimensions from here down to here, you have to add everything together, which is this, and this. So when we add everything together, we're going to get the total length from here down to what here. So now let's do the maths. So we're going to name this reinforcement T4. So now the first one is what 230. I've already explained this. The second one is what 1,765, which is from here to here, 1,765. Then the next one is what? 230. Next is what? 1845. And the last dimension is what? 230. So when you add everything together, what are we going to be having? We're going to be having a total of what? 4,300. So it means that the length of this lintel from here to here is 4,300. So now we're not going to be lessing what? Concrete cover. So we're going to be having a total of what? 4,250. So after this, we're now going to be adding what? Bend, which is what? 2 by 12 by what? 10, and that will give us 214. So when you add everything together, what are we going to be having? We're going to be having a total length of what? 4,490. So we're going to be bringing it to the side for easy what? Correlation. 4,490. So doing this, we've measured for the what? Total length of reinforcements 44. So let me just use my green biro so that I can demarcate it. So this is the lintel we just cut out for here. So the next reinforcement we're going to be looking at will be the reinforcements spanning from this side to this side. So if I zoom in, you'll be able to see it better. So as you can see, this is the reinforcement, the lintel that we're capturing for now, the reinforcement inside this lintel. So if I use my green marker to demarcate it, so you can see that the reinforcement that will be passing here would also be the reinforcement passing here. So we need to determine the length of this lintel from this edge down to this edge, right? So now how do we do that? They told us that the dimension from here to here is 1,946. So we have to also add 230. So now name this P5. So first thing is what? 1,946. Then we'll now add 230. So what do we have? We have a total of what? 2,176. So since this is the total length of the lintel, the reinforcement needs to be inside the lintel. So we're going to be lessing what? Concrete cover. And concrete cover is what? 2 by what? 25. Which should give us what? 50. So when you do the math, you're going to be having a total of what? 2,126. So you know what to do next. Next, you have to add what? Bend. Which is 2 by 12 by what? 10. That will be what? 240. So when you do the maths, what are you going to be having? You are going to be having a total of what? 2,366. So this is the length of what? One reinforcement inside this lintel here. But we know that the reinforcement we have here will be the same as the reinforcement we have here. So we have to multiply it by what? 2 to cater for one reinforcement here and one reinforcement here. So multiply by what? 2. when you multiply it by 2, you're going to be having a total of what? 4,732. So doing this, we determine the length of the reinforcement inside, that's one of the reinforcement inside here and inside what? Here. So the last reinforcement we're going to be looking for will be the reinforcement inside this lintel from here to here. So let me zoom in. As you can see, there will be a reinforcement from here to here. So now if I use my marker now to demarcate it, this is what we're going to be having. We'll be cutting for the reinforcement inside this lintel here. So now, how do we determine the length of this reinforcement? So we need to determine the length of the lintel from this edge right down to this edge. So they told us that from here to here is 1,313, right? So we'll now have to add the thickness of this wall here, which is 230, and the thickness of this wall here, which is what? 230. So now let's do the maths. We're going to be calling that T6. So 230 plus what? 1,313 plus what? 230. And we're going to be having a total of what? 1,773. So now after doing that, what do we do? To determine the length of the what? Reinforcement, we have to minus what? Concrete cover. So less concrete cover, which is 2 by 25. Now giving what? 50. So when you minus this, this is the length of the lintel. So we're going to be minusing concrete cover to determine what is the length of the reinforcement. So the length of the reinforcement will be 1,723. So now the reinforcement doesn't just end being straight. You have to also add what? Bend. So we're going to be adding bend. So the bend now, you know the formula, I've said that before, which will give us a total of 240. So when you do your maths, you're going to be having a total of 1,963. So we're going to be bringing this to the side for easy correlation. 1,963. So doing this, we've measured for what? All the vertical reinforcements inside this what? Lintel. So before we move to the horizontal, we have to determine the total length of what? All the vertical reinforcements that we've what? Catered for. So first on the list is what? 29,410 plus second on the list is what? 10,914 plus third on the list is what? 6,925 plus 4,419 plus 4,732 plus 1,963. We're going to be having a total of what? 58,434. So the total length of reinforcements, that's Y10 reinforcements, we're going to be needing for making the reinforcement to these vertical lintels. The vertical side of the lintels is what? 58,434 millimeters. So now, next we have to do the same thing for the horizontal side of the lintels. Now before we move further, what can you notice with what we've done here? You can see that the way we are measuring the reinforcement, right? I want you to pay attention to the point of intersections. Like you can see this reinforcement going like this would intersect with reinforcement coming like this. So anywhere there's a point of intersection, right? Anywhere there's a point of intersection, the reinforcement must what? Intersect. So this is what I mean. Now let's just see, this is our what? Lintel, like this, the lintel concrete. If you are seeing it from on top, there will be 4 reinforcements inside. So from above, you will only be seeing the 2 topmost reinforcements. So now if you look at this now, this lintel coming like this is intersecting with this lintel coming like this. So now the same thing applies with the reinforcement inside. Now if you look at this reinforcement now, it went straight. This 2 went straight. So it means that the 4 inside the lintel would move straight and end at the edge, minusing the concrete cover like we've done. So now for this horizontal reinforcement coming like this, it would not end here internally. It must intersect, it must overlap the other vertical reinforcements. I don't know if that makes sense. There must always be an overlap between the reinforcement, because it is a chain. That is the essence. It is the chain to like strengthen the building in case of any force that could, bring the building down. That is the essence of what chaining the lintel. So now it means that this reinforcement coming like this would be what intersected with this reinforcement coming like this, and similarly this reinforcement here is intersecting with this straight reinforcement. So now if there was another reinforcement coming like this, right, it must intersect with this one. So the reinforcement now would come straight like this. So this would be the reinforcement, right? It must intersect. I don't know if that makes sense. So that is the idea behind what we have been doing now. So now with this piece of information, now we can now continue to cater for our horizontal side of the lintel. So we're going to be using the same approach that we did when we were measuring for the verticals. So the first horizontal now we're going to be looking at would be the lintel that will be passing from here down to this edge. So you can see that it is intersecting the verticals that we have here. So we need to determine the length from here down to here. So as you can see, they're giving us 3 dimensions. From here to here is 1519, from here to here is 1200, and from here to here is 2869. So we'll be adding all those 3 parameters together. So 1519, we'll call it B1. 1519 plus 1200, and plus 2869. We're going to be having a total of 5588. So you think that the length of this lintel from here to here is 5588. So what do we do to determine the length of the reinforcement that will be spanning there? We will now less concrete cover. So when you do the math, you're going to be having a total of 5538. So after that, we will now add bend to the both sides. So you know the formula. So add bend, which is 2 by 12 by 10, and that's going to be equal to 240. So when you add everything together, that's when you add 5538 with 240, you're going to be having a total length of 5778. So this would be the total length of the reinforcement spanning B1, that's from this side to this side. So we'll now bring it to this side for easy correlation. 5700 and 978. So I'm going to use my marker to demarcate. Let me use a black marker here so that you can see the difference. So this would be the one that we just worked on here. The next horizontal reinforcement that we're going to be looking for would be the reinforcement from here to here. So we need to determine the length of this lintel from this edge down to this edge. So as you can see, they've given us 3 dimensions. From here to here is 1868, from here to here is 1500, and from here to here is 1455. So they're adding everything together. So I'm going to be calling that B2. So 1868 plus 1500 plus 1455 . So when you add everything together, you're going to have a total of 4823. So it means that the length of this lintel from here to here is 4823. So what we need to determine now is the reinforcement itself, not the lintel. So the length of the lintel is just a means to an end. So we have to now less concrete cover from both sides to determine the length of the reinforcement. So we'll now less concrete cover. Which is 2 by 25, and that will be equal to what? 50. So when you do the math, you're going to be having a total of what? 4773. So now this will be the length of the straight bar. So we have to add what? Bend. Just 2 by 12 by what? 10. And that will give us a total of what? 240. So when you add everything together, you're going to be having a total length of 5013 millimeters. So 5013 millimeters is the total length of the reinforcement that we are going to be needing to make the reinforcement inside B2, that is inside this lintel here, from here to here, including the bend. So we'll now bring it to the side for easy correlation. 5013. So let me use my black marker to demarcate the one that we've already done. So this is what B2. So the next reinforcements we're going to be looking for will be the reinforcement inside this horizontal side of the lintel from here to here. So how do we determine the length of this reinforcement or the length of this lintel from this edge down to this edge? So we'll go to our dimension and then determine it. So you can see that the thickness of this wall from here to here is giving us as 230. So we had to add 230. We have to add this dimension 1200. We have to add this dimension 150. We also have to add this dimension 3000. We have to add 230. We have to add 4363, and we have to add 230. That will give us the total length of this lintel from this edge down towards this edge. So now let's do the maths. So we're going to be calling that B3. So 230 plus 1200 plus 150 plus 3000 plus 230 plus 4363 plus 230. We're going to be having a total of what? We're going to be having a total of what? 9403. So 9,403 is the total length of this lintel from here to here. So we're going to be lessing concrete cover to determine the length of the reinforcement. So we'll now less concrete cover, which is 2 by 25, and that will give us 50. So when you do the math, you're going to be having 9,353. So now, if this is the length of the reinforcement inside that lintel, we have to also add bend. So adding bend now will be 2 by 12 by 10, which is 240 mm. So when you do the math, you're going to be having a total of 9,593, which is not up to a standard length of reinforcement, so there's no need for lapping. So we'll bring it to the side for easy correlation. So doing this, we've measured for the reinforcement in B3. So let me use my marker to demarcate it so that you can see. So now you can see what we have here. There's a reinforcement intersecting here, intersecting here, intersecting here, and intersecting here. The horizontal reinforcement has to intersect it. You don't do it in such a way that the reinforcement now, because of there's already an intersection here, it will not stop into in. No, it must intersect them. So the reinforcement now will go like this horizontally. It will intersect, right? So this is how you go about it. So we've done forwards B3. So the next reinforcement now we're going to be looking for will be the reinforcement inside this lintel from here to here. So you can see that the reinforcement will be intersecting this 150 mm wall and this 230 wall. So now we need to determine the length of this lintel from this edge down to this edge. They told us that in to in here is 3,000, as you can see in this dimension here, 3,000 mm. That's from here to here, into in of this wall. So we have to add 150 mm and 230 mm wall respectively. So let's do that. So there was a 150 mm wall, 3,000, which is the in dimension of the wall, and then 230 mm wall. So we'll add everything together. When we add everything together, we're going to be having a total of 3,380. So and this is the length of the lintel, right? We have to now determine the length of the wall reinforcement. First, we'll less concrete cover, which is 2 by 25, and that is 50 mm. So now, when you minus this, you're going to be having a total length of 3,330. This will be the length of the straight bar, but we have to add bend. So we'll be adding bend. So when you do the math, you're going to be having a total length of 3,570. So you will now bring it to the side for easy correlation. So it means that the length of the reinforcement spanning from this point down to this point will be 3,570. So let me use my marker to demarcate it so I can see that we're already done with it. So the next reinforcement we're going to be looking for horizontally will be reinforcement from this edge down to this edge. And now what can you see? You can see that once we've gotten the length of this reinforcement from here to here, it would also be the length of this reinforcement from here to here. So first things first, let's determine the length of this lintel from this edge down to this edge. So how do we determine that now? We can determine that by adding these dimensions, 230, 1000, 230 for this thickness of the wall, 2483, and then 230. When we add everything together, to give us the total length of this lintel from this edge down to this edge. So we'll now write 230, then 1000, 1000, then 230. I've already told you how we cut all these dimensions. Then 2483, and then 230. So when you add everything together, what are you going to be having? You are going to be having a length of 4173. So it means that the length of this lintel from this edge here down to this end here is 4173. But that's not what we're looking for. We're looking for the what length of the reinforcement inside. So we're not going to be minusing what concrete cover. So which is 2 by what 25, and that will give me what 50 mm. So when you minus that, you're going to be having a total of what 4123. So 4123 is the total length of the straight what bar. So we have to add bend. So the bend will be what 2 by 12D, which is 2 by 12 by 10, giving us a total of 240 mm. So when you add everything together, you are going to be having what 4363. So 4363 is the length of the reinforcements passing from here to here. So we'll multiply it by 2 because what we have here will be the same as what we have here. So multiply it by 2. And we'll be having a total of what 8726. So 8726 will now be the total length of the reinforcement for here and here. So doing this, we measure for what the reinforcement as B5. So let me use my marker to what demarcate it so that you can see. So it will span from here down to this edge, and from here down to this edge. So the next dimension we're going to be looking for, or the next reinforcement we're going to be looking for, will be reinforcement inside this lintel from here to here. So now we need to determine the length of this lintel from here to here. They've told us that in to in for this wall here is 1211. So we'll be adding thickness of this wall 230 and the thickness of this wall 230 to get the total length from here to here. So now let's write. We're going to be calling that B6. So 230 plus 1211 plus what 230. We're going to be having a total of what 1671. So this will be the length of the lintel, but we're looking for the length of the what reinforcements. So to determine the length of the reinforcements, we have to less what concrete cover, which is what 2 by what 25. That is what 50. So when you minus that, you're going to be having a total length of what 1621. So this will be the length of the straight bar, but we have to cater for what bend. So we'll now say add bend, which is what 2 by 12 by 10. That will give us 240 mm. So when we add everything together, we'll be having a total of what 1861. So I'm going to be bringing it to this side for easy correlation. doing this, we've measured for the length of the reinforcements at B6, which is at this short side here. So I'm going to use my marker to what demarcate it. So you can see how they intersected, right? Between these two horizontal reinforcements, it intersected them. So that is the idea behind reinforcing your lintels in a chained manner. So the next reinforcements we're going to be looking for will be the reinforcements inside this lintel from this edge down to this edge. So now they told us that in to in from here to here is about 2,337. So we'll be adding the thickness of this wall, which is 230, and the thickness of this wall here, which is what, 230. So let's do the math. We're going to be calling that B7. So 230 plus what, 2,337 plus 230. We're going to be having a total of what, 2,797. So this will be the length of this lintel at B7 from here to here. But we're looking for the length of the reinforcement inside, so let's concrete cover. Which is what, 2 by 25, that will give us 50 mm. So when you minus it, you're going to be having a total of what, 2,747. 2,747. So this will be the length of the straight bar. So we need to add cutter for what? The bend. So we'll now add bend. So 2,747 plus 240, we are going to be having a total length of what? 2,987. 2,987, meaning that the length of the reinforcement from here to here is 2,987. So what can you see? It means that 2,987, which is the length of this reinforcement from here to here, will be the same as the reinforcement from here to here and also from here to here, because you see they are parallel and equal. So what we have here will be the same as what we have here and what we have here. So you will now multiply it by what? 3 to cater for what? These 3 sides, 1, 2 and what? 3. So we're going to be having a total of what? 8,961. So we'll bring it to this side, 8,961. So doing this, we've measured for what? The reinforcement at B7. So let me use my black marker to demarcate it so that you can easily see what we've done here. So on this, you can see how they intersected this and what? This. So the next reinforcement we're going to be looking for will be the reinforcements from here down to this edge. So first things first, we need to determine the length of this lintel from this point down to this point. So we'll be adding 230 from here to here, 3,778, 230, 1,000 and what? Also 230. So we'll be adding them together. So first things first is 230, 3,778, 230, 1,000 and 230. So when you add everything together, you're going to be having a total of 5,468. 5,468. So this will be the length of this lintel from here to here. So we're going to lessen concrete cover to get the length of the reinforcement. So when you minus it, you're going to be having what 5,418. So we'll now add bend, which is what 2 by 12 by 10. That's what 240 mm. So when you add everything together, you're going to be having a total of what 5,658. So we'll bring it to the side for easy correlation. So doing this, we measured for what B8. So this is a reinforcement now we've cut out for. So the last horizontal reinforcement for the 230 mm lintel would be for this reinforcement here. So how do we determine the length of this reinforcement? First, we have to determine the length of this lintel from this edge down to this edge. And to do that, you can see that they've given us some dimensions here. The thickness of this wall is 230, and from here to here is 5,000, and then we'll also add 230. So we'll not do the math. We'll be calling that B9. So 230 plus 5,000 plus 230. We're going to be having a total of what 5,460. So this will be the length of the lintel from this edge down to the what other edge of the wall. So we'll now less what concrete cover to get the actual length of the reinforcement. So I'm going to be having 5,410. So this is the length of the straight bar. So we'll be capturing for the what bend. So 2 by 12 by what 10, which will give me what 240 mm. So when you add the 2 of them together, you'll be having a total of what 5,650. So 5,650 is the length of the reinforcement at what B9. So we'll bring it out for easy correlation. So we've measured for what this side. So as you can see, we've cut out for all the reinforcements for the 230 mm lintels. So the next thing now we're going to be looking for will be the stirrups for this what reinforcement. So as you can see, all the sides that we cut out for lintels when we're cutting for the concrete work, you can see that we've already measured for what their reinforcements. So what is left now will be the stirrups for the 230 mm size lintel. Then we'll now do the same thing for the 150 mm size lintels together with its stirrup. So next we need to do now is to determine the length of the stirrup and the quantity of the stirrup that is going to span throughout this throughout the reinforcements for the lintels at the 230 mm walls. So continuing with what we were doing, we have to determine the total length of the horizontal reinforcement by adding all the parameters from B1 down towards B9. So after adding everything for the horizontal reinforcement, we had a total of 54,810 millimeters. So now the next thing that we need to do now is to add both the vertical reinforcements and the horizontal reinforcements together to get the total length of the reinforcement at the 230 mm sized lintels. So when I say total length what did we get as the total length of our what reinforcement at the vertical side? We had a total of what? 58,434. So we'll write 58,434 plus what? 54,810. So we have a total of what? 113,244 millimeters. So that is the total length of the reinforcement at the 230 mm sized lintels. 113,244 millimeters. So now, doing this now, we have determined the total length of our reinforcement at the 230 mm size lintels. So we now have to what? Describe and then convert it to what? Tons. So we're going to be describing by saying what? High tensile steel bar in what? Lintels. High tensile, let's just say TNT steel bars in 230 mm lintels. So we're now going to what? Book. So we're going to be booking now by converting this in meters. 113,244 millimeters in meters is what? 113.24 meters. So we'll write 113.24 meters. So this will be the total length of one reinforcement inside the lintel. So how many reinforcements do we have inside the lintel? There will be 4 in number throughout. So you multiply it by what? 4. So now, when you multiply it by 4, you're going to be having a total of what? 452.98. 0.96, sorry. So doing this, we measured the total length in meters for what? Our reinforcement inside the what? Lintel. But our unit for reinforcement is in what? Tons. So you have to convert it to what? Tons. So how do we convert this to tons? Easy and straightforward. So you bring your parameter out, which is what? 452.96 meters. So you multiply it by the weight of the what? Reinforcement. So you need to determine what is the reinforcement used for the lintels. And we were told that we assumed that the reinforcement used was what? 10 mm, that's Y10. So how do we determine the weight of Y10 reinforcement? I've told you the formula in our previous videos. The formula is what? D square all over 162, where D is the diameter of the bar. So 10 square divided by 162 is what? 0.617 kg per meter. So the weight of 10 mm reinforcement is what? 0.617 kg per meter. If you want to construct this, go to Google and ask for the weight of Y10 reinforcement. You will see that it will give you this same value. So now when you do your maths, what are you going to be having in kilograms? You're going to be having a total of what? 279.48 kg. So how do we get this kg? Simple mathematics. Meters will cancel what? Inverse of this meter here. So what is left is what? Kg. So you will now divide this by what? 1000 to convert it to what? Tons. And we're going to be having what? 0.28 tons. So this is what you'll be carrying to your bill of quantity as the quantity of reinforcement for the 230 mm lintels. That's the reinforcement inside the 230 mm lintels, the straight bar. This is the tonnage, 0.28 tons. So to calculate for the stirrups to the lintels, the length of the stirrups, you have to bring out a section of your lintels. Okay, so as you can see, we've brought out a caricature section of our lintel. So we know that the thickness of the lintel will be as thick as the thickness of the wall. So it means that from here to here will be 230, and then the height of the lintel will be as high as a block, will be as high as the height of a block, right? And you know that the height of a block is let's say 225, 230. So that's how we got this 230 here. So now, how do we determine the length of our stirrup inside? So what we can do is this. Since we know that this is a square, we can determine the length of one side of the reinforcement inside the stirrups, and then multiply it by 4 sides, because what you have here will be the same as what you have here, 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 and here. Then we can now add the bend. So now let's do that. So how do we determine the length of this reinforcement here? They told us that the length from here to here is 230 mm. So we can minus concrete cover from both sides, and we can see our concrete cover is 25 mm. So we can now do the math by saying 230 mm will less concrete cover. That's 2 by 25, and that's 50. So that will give us a total of 180 mm. So it means that the length for one side here to here is 180 mm. So we'll multiply it by 4. And after multiplying it by 4, we'll have a total of 720 mm. So it means that the length of this reinforcement round is 720 mm. So we'll now cater for bend, which is the bend here and here. So we'll now add bend, and you know the formula 12D. So it will be 12 times what's the diameter? 8. So how many bend do we have? 2. The bend coming like this and the bend coming like this. So it will be 2 by 12D, which is 2 by 12 by 8, and we're going to be having 192 millimeters. So when you add 192 to 720, you're going to be having a total of 912 millimeters. So 912 millimeters is the length of these reinforcements for the stirrup, including the bend. So now the next thing we're now going to do is to determine the number of this 912 mm reinforcement that will be used for the stirrups inside the straight bar. So if you look at this, right, this drawing here, you know that this is a reinforcement. So now your reinforcement now is going to be starting from here, not the intersection, because there will not be stirrups in the intersection. So the reinforcement the stirrups will be coming like this. So now you now need to determine the number of these stirrups, right? So how do we determine the number of these stirrups? You have to first determine what is the length of the reinforcement, right, where the stirrups will be found. So if you look at our drawing, right, where and where are we going to be seeing our stirrups? I told you that there will not be stirrups at the intersections. So it means that we need to determine the in-to-in. It will be inside the in-to-in dimensions. That is where the stirrups will be found. The in-to-in dimensions. Because at the intersections there would not be stirrups. And we've already calculated for the in-to-in dimension for this for this lintel here, right, around this building in our previous video, where we're looking at the adjustment for the lintels when we're calculating for block work, right, for this drawing. So when we're dealing with the adjustments for the lintels, what we calculated was the in dimension. So, and the in dimension we calculated was 93,671. So you can refer back to the video on where we measured our block work during the adjustments for the lintels. The length that we used was 93,671, which was the in dimension. So it means that as the sum of all the in dimensions of where the lintels are, right, the in dimension, we have a total of 93,671. So we're going to be bringing it back here. So the number of the lintels at 200 center to center spacing, center to center spacing. Now we know that the total length in, which is the area, the portion where the lintels are going to be found, is 93,671. 93,671. So we're not going to be dividing this by the center to center spacing, which is 200. So after doing that, we're going to be having a total number of 468 numbers. So we'll add 1 for contingencies. That will give us a total of 469 number. So it means that this 912 mm reinforcement that we're going to be using to make one stirrup, we need it 469 times to cater for all the stirrups that will be laid throughout the lintel at the 230 mm size lintels. Because remember, we have 230 mm size lintels and 150 mm size lintels. We're doing them separately. So doing this now, we can now describe. So we can now describe by saying mild or high steel, depending on the specification you have. So mild steel bar, Y8 as stirrups to lintels, 225 mm size. So we can now book. So what is the length that we calculated? 912 millimeters. Convert it to meters. That's 0.91 meters. So we'll not multiply it by the quantity, and the quantity we've calculated was 469 in number. So multiply by 469. And we're going to be having a total of 426.79 meters. But we do not need this dimension in meters. We have to convert it to tons. So now, to convert it to tons, we have already done an example before. So we're going to be doing it here again. So to convert it to tons, we'll be bringing our parameter in meters, which is 426.79. This to tons. Right, 426.79. So we'll multiply it by the weight of 8 mm or Y8 reinforcement. So we know the formula, d square root over 162. That's to determine the weight of a reinforcement. So what is d? D is 8 mm. So 8 square divided by 162 is 0.395. So 0.395 is the weight of 8 mm reinforcement bar per meter. So 0.395. So if you want to check, you can go to Google and ask for the weight of 8 mm reinforcement. So 0.395. So kg per meter. So it means that it weighs 0.395 kg per every meter. So now we now need to determine the weight in kg. So we multiply this and this together, I am going to be having what 168.61 kg. So to convert it to tons, now you divide this by what 1000. I am going to be having what a tonnage of 0.7 tons, 0.17 tons, sorry. So this is the quantity of Y8 reinforcement that you'll be taking to your bill of quantity to cater for the stirrups to the 230 mm sized lintels. So doing this, we've come to the end of today's video. We're also going to be doing a part 2 for calculating the reinforcement and the stirrups for the lintels that are 150 mm sized, right? That's the 150 mm sized lintels. We are going to be calculating for the straight bars and the stirrups in a separate video. So we've come to the end of this video. Please do not forget to like, share and subscribe to this channel. Thank you.